Hi, this is Chandra Prakash, and welcome to another session on AI. And today we are going to do a detailed discussion on threat modeling. To do this, I have with me Sir Rammohan. Mr. Rammohan comes with 25 years of experience both in technology and leadership roles. He has several years of experience and depth in cloud, managed services, professional services, and consulting, and delivered various projects across US, Europe, and Asia Pacific. He has held leadership positions with major IT services company, which includes that of IBM.
Yeah, hi everyone. This is Rammohan speaking. Very happy to be part of this session. Today I'm going to talk about threat modeling. What is threat modeling and how threat modeling will be done on IT systems, ICS/OT systems, as well as Gen AI systems. I am covering all the three perspectives and how threat modeling will be done in all the three. Now, what exactly is threat modeling? Threat modeling is basically, in simple words, it's anticipating the risks and then design for resilience. So we look into various aspects of threat modeling, and I am also going to talk how important it is and how do we actually go about doing the threat modeling. So this is the agenda. So I first talk about the comprehensive security posture. So that is the organization's maturity or preparedness in terms of doing threat modeling on IT security or ICS/OT security or Gen AI security. And then I'll talk about some real world examples of breaches that have happened and the dire need for threat modeling. And then I will talk about the threat modeling process. I will also discuss the threat modeling frameworks and then how do you actually do the threat modeling differently in AI systems, in IT systems and ICS OT systems. So that will be my agenda. Okay. The first thing is, what does comprehensive security posture mean? See, it's very important that organizations have to know what is their current security posture, where they stand for to do a proper threat modeling. So it starts from there. It's not about just because threat modeling has to be done, you start doing the threat modeling. You will have to first do the comprehensive security posture, do a thorough check and do an inventory of where your organization stands at that point of time. So what does comprehensive security posture entail? Comprehensive security posture entails three things. One is, what is the type of domain? Are you working on healthcare? Are you working on finance? Or is it a manufacturing? Because each one of them has their unique threats and vulnerabilities. And it's not only the use cases, even in terms of whether it is IT system, whether it is ICS OT system, or whether it is a Gen AI system. In fact, in reality, sometimes it could be a combination and overlap of all this, meaning organizations nowadays are very complex. There is hardly any air gapping between ICS, OT, and IT, in the sense that there is some element of intersection between them. So you're probably doing for a threat modeling for an organization that has ICS, OT as well as IT, or IT as well as Gen AI. So the type of domain has to be very clearly captured, and that is where it needs to stand. So that's the first step of comprehensive security posture. So what is the next thing? You will have to actually look at the software maturity levels. You evaluate the maturity of the software. What is the development practices that you're currently following? For example, if you're using DevSecOps, if you're using MLSecOps, or even LLMSecOps, and then what are the security frameworks that you're using? And also, at what stage of the life cycle is your organization in terms of your software maturity level? The third thing you need to know about is the attack surface areas and attack vectors. Very important. So you need to identify what are the potential entry points and the methods in which attacker could exploit or compromise the system. Now, what is attack surface area and attack vector? I just give an analogy. Attack surface area, let's say you take a malaria mosquito. The mosquito is carrying the blood, that is the attack vector. But your skin, where the mosquito sits and bites, that is the attack surface area. All in all, you need to first do a complete comprehensive security posture of your organization, and it will have three parts. As I said, the type of domain, the software maturity levels of your organization at that point of time, and the attack surface areas and the attack vectors. Unless these three are captured, your threat modeling exercise will not yield the results. So that's the first step. What is next? So here I explain you what is the comprehensive security posture that I'm talking about. So basically, when it comes to IT security, you will have to capture the what is the state at this point of time in terms of data confidentiality. Where are you in terms of the data integrity? And what are your data availability strategies that are currently being used in your organization? That is from the IT security perspective. If you're having ICS OT or industrial security, cyber security, then you will have to also look at the physical safety, and you should also look at the operational continuity. And if it is specifically Gen AI security, where you are only working on AI models and AI LLMs, then you will have to look at the model integrity, bias management, and the explainability issues. All in all, apart from this, there are a lot of other things that needs to be there as part of your IT security, ICS OT security, and generative AI security. But fundamentally, these things are imperative. These things are something which you have to have compulsorily to capture your actual comprehensive security posture of your organization. As I told you, so organizations are very complex, and sometimes it may be an intersection between these as well. So your threat modeling has to capture that. Otherwise, as I told you, your threat modeling exercise will not bear fruit. So that step. Next. So before I go into the actual threat modeling, you need to very clearly understand what is the software maturity of your organization at that point of time. So for example, if you're using traditional software, then it will be DevSecOps. So you'll have only data plus applications. If you're using data science or machine learning, that is predictive AI, then you'll have four things: the data, the applications, the model, and the algorithm. Now here you see the complexity is increasing because the attack surface areas are also increasing, and therefore the attack vectors. If you look at the traditional software, we had only two things to contend with: the data and the applications. But now when you go to data science or predictive AI or ML so you had four things to take care: the data, the application, the model, and the algorithm, which means the attack surface areas are increasing and the attack vectors also will increase. Come to generative AI or LLM SecOps, now you have five things here: data, synthetic data, applications, model, and algorithm. So therefore, hallucination, bias, all these come into play when it comes to synthetic data. So as you look at this journey from traditional software to generative AI, that is LLM SecOps, the attack vectors are increasing and the attack surface areas will also increase. So therefore, your threat modeling activity is going to get far more complex. In fact, it's all the more reason you have to do threat modeling when you go to generative AI, because the complexity is increasing, the attack surface areas are increasing, and the attack vectors are increasing. Therefore, all the more reason threat modeling is a fundamental imperative for organizations that are running Gen AI. In fact, even for predictive AI or traditional AI for that matter, and even as I said, a combination or a convergence of all of them. Next, what are the attack vectors and attack surface areas for a traditional software? So I just mentioned a few of them. One of them is the exploitation of software vulnerabilities, the injection attacks, misconfigured DevSecOps pipelines. It could affect the pipelines in terms of having a insecure CI/CD pipelines. It could be a network-based attacks, a DDoS or a man-in-the-middle attacks, and also zero-day vulnerabilities. And what are the attack surface areas for traditional software? It is application code bases, DevOps pipelines. It could be at the build, deploy, or at the monitor level. The network endpoints come into picture, and also the authentication mechanisms in terms of the passwords and tokens. So if you see here, I have listed out only few of them, few important of them, the attack vectors and attack surface areas, but there are many that's going to be there as part of your traditional software. Now, let's look at the attack vectors and attack surface areas for predictive AI or machine learning or data science. So here it is changing. You can see data poisoning for manipulating the training data, adversarial attacks, and model extraction, reverse engineering it, and API exploitation. Attack surface areas, here again data pipelines, the training and production data sets come into picture, application leveraging AI models, and the machine learning models themselves could be the attack surface area. And of course the APIs and the interfaces that are exposing the API. Remember, these are not something which is exclusive. These are on top of what you are getting in the traditional software. So the attack vectors and the attack surface areas of the traditional software are also applicable on predictive AI, On top of that, these are the additional things that are there. So that is like a superset. So you can imagine how the complexity is increasing and why threat modeling should be a very intense and very comprehensive activity that needs to be done. Now, coming to the generative AI. Now, in the generative AI, we have some more attack vectors. The data poisoning, I was telling, in terms of real and synthetic data manipulation, adversarial prompt engineering, it exploiting the LLM weaknesses. Model could be misused. There could be a lot of jailbreak attempts or exploits trying to bypass the restrictions. This could be the attack vectors. And here again, the attack vectors of the traditional software, the attack vectors of the machine learning or ML SecOps software also applicable. And on top of that, these are the supersets. Similarly, for attack surface areas, you have the data pipelines, both real and synthetic, the synthetic data generation systems, the language models, and the API interfaces. So as you go from traditional software to predictive AI, that is machine learning, to attack vectors in generative AI, the complexity is increasing. So this is something you need to remember. Now, I was talking about the examples how if you do not do threat modeling and if you do not close those gaps, what are going to happen? I always refer to some of the very critical, important case studies or live breaches that have happened. Sandworm is a very good example. It's a book written by Andy Greenberg. There it talks about how the ICS OT systems got compromised because of a malware or ransomware that attacked the ICS OT. So what happened with Sandworm? So Sandworm is actually a Russian state-sponsored hacking group, and they actually saw the vulnerability in the ICS OT system, and they have done devastating attacks on the critical infrastructure. So in fact, Sandworm used something called as a black energy malware to cause a large-scale power outages in Ukraine. So this attack actually demonstrates how ICS specific malware can disrupt the entire physical infrastructure and critical services. So the threat modeling should have been done. It should have captured all the scenarios, all the permutations and combinations, and there should have been checks and balances in place. So this is one example of how if you do not have proper threat modeling and checks and balances in place, there could be real data breaches. And you know, data breaches have not only in terms of financial, even in terms of reputation, you have consequences. So then the same Sandworm had another version of ransomware called as NotPetya, and that in 2017 again exploits the weakness this time between IT and OT integration. Remember, ICS OT systems are different and IT systems are different, but the air gapping will never be 100%. There may be some convergence between the ICS OT and the IT system. So therefore, even if one of them gets breached, the automatically the other one will also get affected. So it also, this particular case also exposed the dangers of poor network segmentation between the IT and the OT systems. And therefore the legacy OT systems sometimes often lack cyber security features. So that makes it far more vulnerable for exploits. So this actually, Sandworm, it actually capitalized on what? Unpatched vulnerabilities and poor network architecture. Now, all these could have been captured if we had done a proper methodical threat modeling on the systems. So these are now not only just data breaches, these are geopolitical cyber warfares now to destabilize economies. And on top of that, imagine this Gen AI or machine learning is getting added as on top of the mix. Hackers are using AI to or machine learning to generate these malwares. You can imagine the complexity. Already you have ICS OT system and IT system convergence to an extent. On top of that, you have the Gen AI getting added to the mix. So it's a deadly concoction. So the threat modeling becomes far more complex, but all the more reason you have to do threat modeling because there's no other go. Because you'll have to capture all the possible, chinks in the armor in your systems. Another example after ransomware, which I talk about, is the Colonial Pipeline ransomware. This happened in 2021 on the east coast of US. What is this? This is again an attack to disrupt the fuel supplies in the east coast of US, and it targeted the IT system And also it targeted the IT system which were actually managing the OT system. So this was a dark side ransomware that exploited a compromised VPN account, and then it led to a preemptive shutdown of OT system. You can imagine the amount of money, the reputation damage that could have happened to this organization. So this also highlighted how weak the IT and OT segmentations are there, and you can amplify those disruptions if a ransomware attack happens. And in fact, the operations halted for nearly a week, and it caused fuel shortages, economic losses, and of course the ransom payment. Can you believe that? So this exposes the critical infrastructure's vulnerabilities to ransomware, and it also emphasizes there needs to be a stronger IT/OT cybersecurity convergence and integration. Very important. Similar example, third example I want to give is of Stuxnet in 2010. Uh, What is this about? This is about a sophisticated cyber weapon, a malware which was designed to sabotage Iran's nuclear program, and it was targeted the centrifuges at the Natanz facility. So in fact, it had infected the USB drive to bypass the air gap systems and exploit the zero-day vulnerabilities. And this also it bridged the IT and OT environments, but it exposed the vulnerabilities in by trying to isolate the ICS OT systems, but it used a USB drive to bypass that. You can imagine. In fact, the attack destroyed almost about 1,000 centrifuges. So these are the some of the things which I wanted to give as real examples as to how, if you do not have a comprehensive security posture captured, and you do not do a thorough threat modeling on your systems, then the breaches are going to happen, money you are going to lose, reputation, whatnot. So how does now next question next is how does the threat modeling process happen? So there are fundamentally four questions that you need to answer in threat modeling before you start. What are they? What you are building? What can go wrong? What are you doing to mitigate these risks? And how did we do a good enough job? So these are the fundamental four questions that you need to answer if you want to do a proper threat modeling. That's the process. Threat modeling process asks you fundamentally to answer these four questions. So what are they? First, what are we building? So what are the system components? What is the application architecture? Nowadays, new compliances are coming that's talking about maintaining a SBOM, software bill of materials. So it becomes all the more important to maintain the software bill of inventory, because then you will know what software are there, what is the version of that software, what is the patch levels of that software, whether all the third party risks have been captured, all the information about the software is captured, all these are there. So system components, application architecture becomes important. That's part of what are we building. What can go wrong? So you'll have to see threat identification, and you need to do a vulnerability assessment. So you have to look at the impact and priority and see what are the threats that can be there, what are the vulnerabilities, what can go wrong. The next one, what do you do to mitigate these risks? So you'll have to have proper security controls, and you have to have a risk mitigation strategy. Now this, and then did we do a enough good enough job? So you'll have to check the effectiveness, and you have to continuously improve. By the way, threat modeling is not a one-time activity. You do it once and then you feel that it is done. Because as threats keeps changing, dynamic world of threats and ransomwares, you'll have to keep your A game always when it comes to threat modeling. So threat modeling has to be done regularly, it has to be updated, and it has to be kept current. Otherwise, your entire process will of no use, because the data has to be constantly updated. So probably for any customer or any of your use cases, you'll have to do at least 4 times in a year. Do a threat model, maintain the baseline version, and then after 3 months, do another cycle of threat modeling, see what is the incremental changes, update that, and capture that. Capture your old threat model outcomes at the same time. Also capture the updated threat modeling outcomes, and check what is the difference, and then keep that updated. So these are the four things that you need to, your threat modeling process will answer. So end of the day, you need to evaluate whether your threat modeling is actually marked to the outcomes. So I know that you cannot have 100% security, but by doing a proper threat modeling exercise and properly having the threat modeling process in the organization, having people trained on threat model, and maintaining all the baselines and maintaining all the versions of the outcomes of the threat model, you can actually you can ensure that you will not have the probability of the breaches will come down to a large extent. As I said, 100% you cannot eliminate, but even if you maintain this and follow the practice, there is a huge change in terms of your security posture because you are reducing the probability of breaches by a large extent. So therefore, I cannot emphasize more how much threat modeling is very important for any organization. So what are the different threat modeling frameworks we have? Now, by the way, I have listed out 4 or 5 important frameworks here. Linden is basically from the privacy aspect of it. Stride is a very common threat modeling way where you take in terms of spoofing, tampering, repudiation, in terms of information disclosure, denial of service, and elevation of privileges. Similarly, DREAD, these are all the acronyms for each the different ways you can do threat model. MITRE attacks using tactics and techniques, and attack trees using security goal and attack vectors. By the way, it's not written in stone that you have to use these frameworks. You can create your own customized framework for your organization. Nobody tells you that threat modeling has to be only Linden, threat modeling has to be only Stride, has to be only Dread. You may have to use in combination of these, depending on the business, depending on your customer, depending on your domain. I told you whether it is ICSOT or whether it's IT or even it's a pure Gen AI system. So you can use that in combination. So there is no hard and fast rule that you have to use only a particular model. You could use a combination of that. You can create your own threat model, a method, and do that. Ultimately, the idea is, have you captured all the possible vulnerabilities, all the possible threats, and anticipated and recorded it so that you have a baseline for you to refer in case there is a breach happened, and whether your threat model has actually captured or anticipated that, and you have that information with you. So it's very important. So to answer it again, or to reiterate it again, there could be different ways you can do threat model. You can design your own ways. Ultimately, the idea is to ensure that your comprehensive security posture of your organization is maintained or strengthened. Okay. So the slight difference in terms of how you do threat modeling on ICS. So even here, if you see, it is also attack trees for ICS specifically, MITRE attack for ICS, Stride for ICS, and there is a standard called as IC 62443. I have gone through that. It's a very comprehensive standard. You could follow the standards and you can do the threat modeling accordingly. Similarly, there are guidelines given in NIST SP 800 guideline for ICS. You can follow the security guidelines and the implementation strategy. So these are very specific to an ICS OT system. But if you see, the fundamentals remain the same. Only thing is it is customized to the ICS OT framework. Similarly for AI, what about threat modeling frameworks for AI systems, pure AI systems? You have AI specific Stride, you have Linden privacy for AI, and then you had OWASP guidelines are there for top 10 for ML security. You can use the MITRE Atlas and you can use the PASTA for AI. So for AI systems, there are also versions of threat modeling which is based on the IT threat modeling, but very customized for AI specific needs. So all in all, your threat modeling has to take care of, if at all your systems have an integration between ICSOT, IT security, and Gen AI, you will have to factor in that, and you need to create a comprehensive threat model. Or if you just have IT security system, then you will have to have a threat modeling done for your IT security system. If you have a portfolio of our companies with you for different domains and different areas, then you will have to have different threat modeling done, maybe a slightly different version of it. But whatever be said and done, you will have to maintain a threat modeling for all the use cases or all the domains or all the customers that you have, and do it regularly and maintain those baselines. Maybe you can have a unified portal where you can have all these threat models like a dashboard, and you can see pretty much filter it down by threat model, by an organization, by a domain, by a use case, and you see how many iterations of threat model has done, and you can actually backtest and see whether any breaches have actually bypassed which the threat model did not capture. So all in all, I am a big advocate of threat modeling, and I have very clearly explained you in this presentation as to what are the things that you need to do in the beginning before you actually start the threat modeling in terms of prerequisites. I also talked about what are the different types of organizations you have, and also I talked about different domains like ICSOT, IT security, Gen AI. I also talked about the intersections of convergences that can happen. So all in all, this is what I wanted to share with you. So are you ready to do the threat modeling? It's an imperative. It's an idea whose time has come. Many organizations have a threat modeling practice in their companies, and it's high time you also have a very specific threat modeling practice in the organization where your workforce is upskilled and they are ready to serve your customers and they are able to do threat modeling successfully. Thank you. This is Rammohan signing off. See you in another video some other time. Thank you.
So, Mr. Ram, the first question is that what is the difference between an AI risk assessment versus an AI threat model? Because in AI risk assessment too, we are identifying the risk based on regulatory and our assets and our business use cases and identifying threat vulnerability pairs and then providing controls around it. So how it is different from threat modeling for AI systems?
See, the way I look at it is that threat modeling acts as a feeder to the AI risk management process because there are some things, see, you cannot do just your risk assessment or the identifying is purely from the compliance aspect of it. But threat modeling is far more superset, where you are not only looking for the compliance, it acts as a feeder to the compliance. You are actually seeing whether there are any inherent flaws in your system. So threat modeling is a bigger practice or a bigger, it has a bigger scope or a canvas or just confined to the AI risk management practice. But as I said, it will act as a feeder. You can use that data, whatever results you come out of the threat modeling exercise can be used for your compliance. But threat modeling covers a whole lot of things apart from just getting into the risk aspects of it.
Okay. So does threat modeling also cover certain abuse cases that we need to test and it helps us in testing for security controls based on those threat actors and exploiting the attack surface?
Yeah, very, very interesting question. In fact, there is a type of threat modeling we do called as agile threat modeling. In the agile threat modeling, we are going to use user stories and the abuser stories, and the scenarios are mapped, epics are created, and the stories are written, and then you are mapping out, trying all permutations and combinations, and trying to see what is the user story, what is the abuser story, and you are wearing the hat of a hacker, and then you're also wearing a hat of somebody from the what you call blue team as well as the red team, and you're mapping out all the scenarios. So in summary, yes, the user stories will have abuser stories, or in the other words, an abuser story or the abuser epic will have a user story, and then you map that to ensure that threat modeling is done in a particular way, looking at in the agile methodology.
Sure. Thank you. The third question is around automation. Are there tools available that helps you guide as well as automate to bring in efficiency the entire AI threat modeling process?
Absolutely. There are tools. I don't want to take the name of the companies because it doesn't look nice. But to answer, yes, there are many organizations now are offering tools, end-to-end threat modeling. They offer all the types of threat modeling that I mentioned, and a lot of other additional threat modeling methods or frameworks are offered. And also, you can customize your own threat model. I told you when I talked about in the presentation, every organization's requirements will be unique. So you could use that tools to create your own threat models and keep constantly updating that threat models so that a lot of manual work can get eliminated. And you can have the code base and you can have those UX and UI designs, everything preserved with a version. So then what happens is that today you are using a particular version of the tool, automated tool. Tomorrow you are using another version. You can do a difference and check what is the difference as well. So you can see it will also help in creating reports for the senior management. Somebody wants to know how many threat modeling activity, how many cycles of threat modeling has been done, what are the outcomes of that threat modeling. Can you compare and contrast 3 months before what is the outcome to the one which you have generated now? All that can be automated. To answer, yes, there are automated tools.
Sure. Uh, if I use a set of LLM scanners to test the code for vulnerabilities, and if I test OWSP top 10 like prompt injection, input output validation, and data poisoning, etc., is this not sufficient, or do I really need a threat modeling, a kind of complex process, and then create abuse stories, and
Yeah.
then go and test comprehensively?
What happens is that this LLM top 10 is basically, outcome of or the culmination of the surveys that they do and then get it from across the world from different organizations who are doing that. But every day, new kind of a threats are coming up, and even the machine learning algorithms themselves are getting changed, or even the way data is been put into the system was getting changed. The machine learning, the how it learns from the data is getting changed. For example, you use the ASCII. If somebody is trying to penetrate using the ASCII, now that's a new thing that has come up. And now if people start using agents or function calling to enter to penetrate into the LLMs, then the standard ones will not change. And by the way, the top 10 keeps changing time to time. So you never know. Today you may be using a particular set of top 10. Tomorrow, the top 10 priority will also change. Something is three becomes one. So it's a constant change or a flux that is happening. So what you are doing may be necessary but not sufficient. So that's why I said use the OVAS as a base, but you cannot be hung up with that as that is what is going to be the final one, because the organization, the requirements keep changing time to time, and the dynamics of the domain which you are testing is different. For example, if you're doing for healthcare, it's a different dynamic altogether. If you're doing for finance or banking, that's a different dynamic altogether. So those top tens may also change depending on the domain. I mean the priority. So to answer in one statement, no, it is not enough. It is necessary but not sufficient.
Okay. So one last question from my side, and this I believe is very important considering how AI systems work. So when we do threat modeling for applications, the basis is the code. We know how the application is going to behave, where it is going to integrate, what are the languages it is being written to, and how many intersections it will have, what kind of data it stores, so on and so forth.
Correct.
But an AI system is very different, wherein there is no code,
Correct.
and the prompt engineering skills are such that you can use the AI systems as you want, both in a good as well as maybe not so good way.
Correct.
So, how do you ensure that we do threat modeling for AI systems, and is it going to be constant, or we have to constantly keep on doing threat modeling for AI kind of systems when major changes occur?
Yeah. So you to answer in one word, yes, you have to constantly keep. For example, I'll give an example. Let us say you have all the guardrails in place, but still somebody has to test those guardrails. And if you are a very smart prompt engineer, you can do a set of chain of prompts and trying to break into the system. And you never know, one of these prompts may actually break into the system. How many scenarios can the red teaming, which does on the AI systems, can actually map out? It's humanly not possible. So it's a constant cat and mouse. People have to start trying all combinations and all permutations, and then you'll have to, even in spite of the guardrails, you'll have to keep constantly checking. By the way, the data that is getting input into your system is also changing time to time. So the upstream, it's not just downstream. Your downstream will get affected by your upstream, whatever is the quality of data that is going into the system. So bias will come, hallucination will come. Even if your prompt engineering skills has to be best, and even with that, there could be a lot of permutations and combination that needs to be constantly keep validating. Otherwise, it's not going to work. And I would say you should have an AI system which can do all this. For example, you have something called as Stride GPT. It's an open source. It's an AI system that does threat modeling for you. In fact, you
Okay,
can go to that tool and you can say which kind of a threat modeling you would like to do, Stride or Linden or whatever it is. So it will automatically do a threat modeling for you and do that particular framework and generate. But having said that, human in the loop becomes very important. You can have an AI tool to do a threat modeling for you. You can have a AI tool to actually create a unified threat modeling portal where you can store all the contents or all the threat modeling done there. But having said that, the human in the loop becomes very, very important. It's always 80% tool and 20% human loop. And if that 20% is missing, then it will not be a successful threat modeling exercise. Even though you have a AI system, even though you have tools that can help you to do the threat modeling.
sure. So, Mr. Ram, if people want to reach out to you as you are a freelancer for any programs or consulting engagements, either on design thinking, on AI security, or threat modeling, please let us know how people can reach out to you.
Yeah, sure. I will share my email ID, that is rammohan@aiproduct.in. People can reach out to me on that. And then I do very unique and very customized trainings on AI security, and also on all the other aspects of ICT, OT, as well as IT security. And my sessions are all design thinking based sessions. It's not boring people sitting and then listening to something. I make people do that, so they will really enjoy, they will learn really a lot from design thinking workshops on threat modeling and AI security.
Sure. Thank you. Thank you,
Thank you.
Raman.
Thank you.
Don't forget to like, share, and subscribe. And also press the bell icon to stay notified of all the future released videos. See you in the next one. Thank you.